Hello, good morning. My name is Garcia-Lodeiro, and the presentation that I'm going to show you has the title, Producing Innovative Repair Micromortars with Hydrophobic Performance. This work has been developed under the European project InnovaConcrete. Well, it is well known that the concrete structures can suffer different kinds of decay processes. Regardless the type of attack, the consequence for the concrete are going to be the same, and it's an increase in its porosity, its permeability, and the consequent cracking. Nowadays, the most common strategies employed to delay concrete degradation are related to modifications carried out during its fabrication process. However, in the particular case of the old concrete-based structures, especially those built in the 20th century, no particular care was taken. Well, a common methodology to reduce the porosity and to avoid ingress of water and aggressive agents in cultural heritage materials, like an stone, is the consolidation and the waterproofing, whose respective objectives are to recover the cohesion of the substrate and to avoid ingress of water and other aggressive agents that will weaken the material, compromising its stability and its durability. Under this InnovaConcrete European project, we are developing innovative impregnation treatments specially designed for concrete. These kind of treatments are based on alkyl silanes, and the novelty is that they're going to be able to react chemically with the substrate, with the concrete, especially with the Portlandite, to produce thiacid gel. Well, the advantage of this kind of treatments is that due to the thiacid gel production, these are going to be 100% compatible with the original substrate. And what is more, they are going to be able to heal microcracks and cracks lower than 1 millimeter. However, when we have cracks much more wider than 1 millimeter, these impregnation treatments are not so effective, and it is going to be necessary the application of repair micromortars to heal these cracks. Well, considering all these facts, one question arises, and is how must be a repair mortar for the concrete-based cultural heritage? Well, these mortars must cover basically 3 requirements. First, they must be compatible with the original substrate. Second, they must have similar features like color and properties like the porosity with the substrate. And finally, they must show mechanical compatibility with the original substrate. That is to say, they must show similar or even lower mechanical strength developments. Well, considering all of this, our objective was to develop a new repair micromortar with a high fluidity and medium viscosity to be applied via injection in the cracks of the mortars and concrete substrates. Well, these mortars must have a good stability of volume, good adherence, compatible mechanical strength, and a hydrophobic performance is desired. Well, let me turn now to show you the experimental procedure. In this slide, I show you the raw materials that we have used in the design of the repair micromortar. So we have used a white cement to facilitate the color adjustment, the final color adjustment. We have used 2 different types of siliceous sands with different maximum particle size, 0.5 and 0.35 millimeters. We will use one sand or the other one depending on the thickness of the crack that we want to repair. We have used several types of commercial chemical admixtures, which are going to be incorporated into the mortar to control the rheological parameters, such as the fluidity and the viscosity, but also other properties, the volume stability and adherence. And finally, we have incorporated the InnovaConcrete UKTP products, which are multifunctional products based on a mixture of a silica oligomer, a surfactant, and a polydimethyl siloxane. This last one has been added to provide the hydrophobic performance. The polydimethyl siloxane has been incorporated in 3 different proportions, 10, 28, and 56% of weight. Well, with the previous raw materials, different dosifications were tested until to obtain 2 reference mortars. The first one, MR4, prepared with the sand P, was specially designed to seal cracks equal or higher than 5 millimeters, and the other one was specially designed to seal cracks with lower thickness. In both cases, we have used a water-cement ratio of 0.35, and the sand-cement ratio was around 1, slightly higher in this first case. As you can see, we have used several types of chemical admixtures to improve the different properties. And we have modified these parameters until to obtain the reference mortar with the desired viscosity and with the desired fluidity. Once we have these mortars, we have incorporated the InnovaConcrete products with a different proportion of polydimethylsiloxane, and we have incorporated these products into the fresh repair micromortar during the mixing procedure in a proportion of 3% of weight. Well, with these dosifications, we have prepared several types of mortars in order to test different properties. So we have analyzed the mechanical strengths, we have analyzed the stability of volume, and we have measured the HYDRIC performance through the analysis of the capillary water, the low pressure water absorption, and finally the contact angle. We also have tested the adherence to these repair micromortars to the traditional OPC substrates, and for that we have prepared several types of standard mortars with simulated cracks with different thickness from 2 to 9.5 millimeters, and then we have sealed these cracks with selected previous repair micromortars. Well, so in this slide, I show you the results corresponding to the mechanical strengths. In general terms, the incorporation of InnovaConcrete products reduce the mechanical strengths, and this reduction is higher with the increasing of the proportion of polydimethylsiloxane in the mortar, in the product. And however, we can see after 28 days that all the mortars shows mechanical strength values over 50 megapascals, which is more than enough for this kind of substrates. With respect to the volume stability, all mortars show a compensated shrinkage lower than 0.1% after 28 days, which is not too bad considering the high proportion of the cement in the repair micromortar, as well as the severe drying conditions. And these mortars were stored at laboratory conditions at 30% of relative humidity and 23 Celsius degrees. And with respect to the hydric properties, we have to point out that the incorporation of these UKTP products reduce the water absorption and the capillary water, the highest proportion of polydimethylsiloxane in the product, the better hydrophobic performance. Finally, with respect to the contact angle, here in this table I show you some of the results. With respect to the reference mortar, we can see that this doesn't show hydrophobic properties per se. The contact angle, it was lower than 90 degrees. However, the incorporation of the polydimethylsiloxane, this UKTP product, has an important impact in this value, especially for the highest proportion, the product with a proportion of 56% of polydimethylsiloxane, where a hydrophobic character was observed. The angle was higher than 90 Celsius degrees. So this last mortar was selected to be applied in the standard mortar with the simulated cracks. Well, so as we have commented before, we have tested the adherence of these repair micromortars to the traditional OPC substrates. So for that, the bigger specimens, cylinders with a crack of 9.5 millimeters were sealed with two formulation, the mortar reference and the same mortar with the UKTP products with the highest proportion of polydimethylsiloxane. And once these cracks were sealed and the mortar were cured for 28 days, these mortars were subjected to the Brazilian tensile splitting strength test. As we can see in this table, in all the cases, the mechanical strength values overpassed the 4 megapascal, indicating that the repair micromortar was perfectly integrated in the OPC sound matrix. The ultimate failure of the bonding, usually associated with the debonding of the repair material and the mortar substrate, did not happen, indicating a perfect adherence to the substrate. Finally, the capacity of the sealing was also tested in the smaller specimens with the selected repair micromortars formulation, and this was evaluated. The sealing was evaluated with the low pressure water absorption test. As we can see in this table, the water absorption values are very low, lower even than the ones obtained in the traditional OPC standard mortars, and similar to those measured in the reference mortar, indicating that the repair micromortar not only has sealed perfectly well the crack, but also its water permeability is lower than in the original substrate. So finally, to conclude, I would like to point out that the incorporation of the UKTP products decreased the mechanical strength. However, in all the cases, the compressive strength overpassed the 50 megapascals, value compatible with the original substrate. That the incorporation of the UKTP products into the fresh repair micromortars, especially those in the highest dosification of polymethylsiloxane, improved considerably the HYDRIC properties. And finally, the sealing of cracks simulated OPC substrates was very effective, showing a perfect adherence to the substrate. And that's all that I wanted to show you. Thank you so much for your attention.